In our lesson today, we're going to continue to practice solving inequalities. And so it's going to be important for us to review what we talked about last time. There are a couple of key phrases that we need to be aware of. The inequality symbol is preserved means that the inequality symbol will stay the same. Okay, when you preserve something, you keep it the same. Preserves the inequality symbol will stay the same. When we say that the inequality symbol is reversed, that means that the inequality symbol changes to the opposite symbol. Okay, so if it was less than, we'll change it to greater than. If it was greater than or equal to, we'll change it to less than or equal to. All right, the inequality symbol is reversed, means that the inequality symbol changes to the opposite symbol. And our big focus on our last lesson was adding and subtracting with inequalities. And we found out that anytime that we added or subtracted with rational numbers, that preserves the inequality symbol. Adding and subtracting rational numbers will always preserve the inequality symbol. In table number 1, we're going to investigate what multiplication and division will do to the inequality symbol. Okay, and this is set up just like the last table in the last lesson that we did. We have die number 1 and die number 2, and I've already got the numbers that we're going to use for this table. And we're going to see the original inequality. So in the one that I did for you, 3 is greater than negative 2. And what we're doing with both of those numbers is multiplying them by negative 2. So I did 3 times negative 2, and then I did negative 2 times negative 2. 3 times negative 2 is negative 6, and negative 2 times negative 2 is positive 4. Negative 6 is less than 4. Notice here that the inequality symbol reversed. Originally, we had a greater than symbol, but after doing the operation of multiplying by negative 2, it has changed to a less than symbol. So this is the first case where we've seen that the inequality symbol is reversed. So we're going to do a few more examples. Pay attention and see if you can tell when the symbol will be preserved and when the symbol will be reversed. Our next set of numbers are 2 and negative 4. 2 is greater than negative 4. And what we're going to do to both of these numbers is multiply them by negative 3. So we're going to do 2 times negative 3. And we're going to do negative 4 times negative 3. And we're going to see if the symbol stays greater than. Well, if we do 2 times negative 3, that's negative 6. And negative 4 times negative 3 is positive 12. Negative 6 is less than 12. So notice here that the symbol was reversed. Okay, multiplying by negative 3 reversed the inequality symbol. In the next examples, we have 6 and negative 1. 6 is greater than negative 1. And what we're going to do is divide both of these numbers by negative 2. So I'm going to do 6 divided by negative 2. I'm going to do negative 1 divided by negative 2. And again, I'm going to see if my symbol stays greater than. 6 divided by negative 2 is negative 3. Negative 1 divided by negative 2 is positive 5/10. All right, that's positive 1/2. Negative 3 is less than 1/2. So once again, our inequality symbol was reversed. Okay, so dividing by negative 2 also reverses the inequality symbol. Our next example is negative 5 and positive 3. Negative 5 is less than positive 3. And we're going to divide both of these numbers by 4. So we'll have negative 5 divided by 4. And we'll have 3 divided by 4. And is the symbol still less than? Okay, so let's use our calculator. Negative 5 divided by 4, that's going to be negative 1 and 25 hundredths. 3 divided by 4 is 75 hundredths. Negative 1 and 25 hundredths is less than 75 hundredths, so our symbol here was preserved. Preserved. Dividing by 4 preserved the inequality symbol. With the last example from our table, negative 6 is less than negative 4. We're going to multiply both of these numbers by 3. Negative 6 times 3 and negative 4 times 3. And will our symbol stay as a less than? Well, negative 6 times 3 is negative 18. And negative 4 times 3 is negative 12. And negative 18 is less than negative 12. So once again, our inequality symbol was preserved. And so what I want you to do is look at the results. Notice when the inequality symbol was reversed. Notice when the inequality symbol was preserved. Can you tell when the symbol should be reversed versus when it should be preserved? So after working on table number 1, I'm hoping that you can tell when the inequality symbol would be preserved versus when it would be reversed. And we're going to test our theory here in table number 2. Okay, so taking a look at table number 2, I want you to pay attention to this column right here, the operation column. Can you tell based on what's happening in that column if the symbol will be preserved or if it will be reversed? Okay, in the top row of the table, I did the first one for you. Negative 2 is greater than negative 4, and we multiplied both of those numbers by 1/2. Negative 2 times 1/2 is negative 1. Negative 4 times 1/2 is negative 2. Negative 1 is greater than negative 2, so multiplying by 1/2 preserved the inequality symbol. Okay, so if you had a theory from table number 1, hopefully this example confirms your theory. And what I want you to do, I'm going to have you copy down the inequalities that I've already set up in the table. And once again, you're going to pay attention to the operation column. What I want you to do in the last column before we do any of the work is tell me, will the inequality symbol be preserved or reversed based on the operations that you see in this column right here? Okay, so go ahead and fill in either preserved or reversed based on the operations that you see. So now let's go ahead and look at our results and see if you were correct. Were you correct when you said that the symbol would be preserved or when the symbol would be reversed? Hopefully you were. Looking at the first example here, when we multiplied both of the numbers by 2, our inequality symbol was preserved. In each case, the inequality symbol said greater than. When we divided by 2 with the second inequality, okay, the inequality symbol once again was preserved. It was less than in each example. So multiplying by 2, dividing by 2 preserved the inequality symbol. In the third example, we divided both of our numbers by negative 1, and notice here that our symbol reversed. Originally, we had negative 3 is less than 2, and then when we divided the numbers by negative 1, we had 3 is greater than negative 2. So dividing by negative 1 reversed the inequality symbol. And when we multiplied by negative 1 in the last example, once again, our symbol was reversed. Negative 1 was less than 3. But when we multiplied those numbers by negative 1, we ended up with 1 is greater than negative 3, so our symbol reversed. So let's review. When will the inequality symbol be preserved and when will the inequality symbol be reversed? It's important to know the answers to these so that when we solve inequalities, like in example 1 and number 2 underneath, we know what to do with the inequality symbol. The inequality symbol is preserved, if we remember from our last lesson, whenever you add or subtract a number. Okay, in the last lesson, we saw that anytime we added and subtracted a number, the inequality symbol was preserved. And in today's lesson, we've discovered that it's also preserved. So, or when you multiply or divide by a positive number. In all of the examples that we did today, when we multiplied or divide with positive numbers, the symbol was preserved. So when will the inequality symbol be reversed? Well, let's put a nice big star next to this because this is very important to know. The only time that you reverse an inequality symbol is whenever you multiply or divide by a negative number. In all of the examples in our tables today, whenever we multiplied or divided by a negative number, we reverse the inequality symbol. So when we look at the examples in number 1 and number 2, pay attention to what you're doing in each step so that you know what to do with the inequality symbol. In example 1, it says 2n minus 3 is less than or equal to 7. Remember that your goal, just like solving with an equation, is to isolate the variable term, all right? The variable term is on the left in example number 1, but it's not alone. It's got the constant -3 with it. So the first thing we're going to do is add 3 to each side. On the left, -3 plus 3 is 0, leaving us with 2n. And on the right, 7 plus 3 is 10. And we just added, and we saw up above that adding will preserve the inequality symbol. So it's going to stay less than or equal to. Now we have 2n is less than or equal to 10, but I need the value of n. All right, so I'm going to have to divide each side by 2. On the left, 2n divided by 2 is the 1n that we're looking for. 10 divided by 2 is 5. And we just divided, but we divided by a positive number, which will again preserve the inequality symbol. So our solved inequality now says that n is less than or equal to 5. When we graph that on the number line, we find 5, and since we can be equal to 5, we're going to need to have a closed circle. So I put a closed circle on 5. And now I need all the numbers that are less than that, so I'm going to shade the number line to the left. And don't forget that we also need to bold the arrow in the left-hand direction as well. Any one of these numbers that we've shaded in would be a solution to our original inequality. Okay, take a look at example number 2. Looks similar, all right, but there is one little difference here. -2n minus 3 is less than or equal to 7. Once again, our first step in this example is going to have to be to add 3 to each side so that we can isolate the variable term on the left. -3 plus 3 is 0, so we're left with -2n on the left. 7 plus 3 again is 10 on the right. And adding, once again, will preserve the symbol. So we have -2n is less than or equal to +10. Now we need to get the value of just n. Right now, n is being multiplied by -2, so we're going to have to divide by -2. And if I did it on the left, I'm going to have to do it on the right. On the left-hand side, -2n divided by -2 is our +1n. 10 divided by -2 is -5. And we just divided this time by a negative number. All right, right here we said that dividing by a negative number will reverse the inequality symbol. So now it's going to say that n is greater than or equal to -5. And that is the answer to this inequality. N is greater than or equal to -5. So when we graph this, we find -5. And since we can be equal to it, we put a closed circle on -5. And now I need all the numbers that are greater than -5, so I'm going to shade my number line to the right. And once again, don't forget to bold the arrow in the right-hand direction. So any of these numbers that we've shaded in would be a solution to the inequality. We reversed the symbol because in the last step, we divided by a negative number. Let's go ahead and do some practice with solving inequalities, okay? Once we solve our inequality, we're going to graph the solution on the number line. In letter A, we have -3m plus 8 is less than 32. Our variable term is on the left side of the inequality, but it's not alone. It's got that constant +8. So our first thing to do would be to subtract 8 from each side so that we can isolate that variable term. On the left, 8 minus 8 is 0, leaving us with -3m. On the right, 32 minus 8 is 24. And since we subtracted, that will preserve the symbol. So -3m is less than 24. Now we need to get the value of m. Right now, m is being multiplied by -3. So we would have to divide by -3 in order to get the value of m. Let's divide 24 by -3 as well. On the left, -3m divided by -3 is our +1m. 24 divided by -3 is -8. And since we just divided both sides by a negative number, what we're going to have to do is reverse the symbol. So now m is greater than -8. And so I'm going to find -8 on my number line. Since I can't be equal to it, I need an open circle. And now all of the numbers greater than -8 would be to the right. So we're going to shade all of these values to the right of -8. and bold the arrow in the right-hand direction as well. Any of these values shaded would be a solution to the inequality. In question B, we have 87 is greater than or equal to 4m minus 13. Notice here that the variable term is on the right-hand side. With inequalities, we always want the variable on the left-hand side. So I'm going to start by rewriting my inequality first. I'm going to have 4m minus 13 on the left. I'm going to put 87 on the right. And since I switched around the order of these terms, I'm going to switch around my inequality and make it say less than or equal to. So this is the inequality that we are going to solve. 4m minus 13 is less than or equal to 87. All right, the variable term is on the left. It's got a constant negative 13 with it, so we're going to start by adding 13 to each side. On the left, negative 13 plus 13 is 0, leaving us with 4m. On the right, 87 plus 13 is 100. And we added, which preserves the symbol. 4m is less than or equal to 100. Now we get the value of m. Right now, m is being multiplied by 4, so we're going to divide by 4, and we'll do the same thing to the 100. 4m divided by 4 is our 1m. 100 divided by 4 is 25. We divided by a positive number, so our symbol will be preserved. M is less than or equal to 25. So we find 25 on the number line. We can be equal to it, so we need a closed circle. And the values that are less than 25 are to the left, so we'll shade all of those values, and we will also bold the arrow in the left-hand direction. In question C, we have negative 8j minus 9 is greater than 47. Our variable term is on the left. It's got a constant negative 9 with it, so we'll start by adding 9 on each side. On the left, negative 9 plus 9 is 0, leaving us with negative 8j. On the right, 47 plus 9 is 56. Adding will preserve the symbol, so negative 8j is greater than 56. Now we need to get the value of j. It's being multiplied by negative 8 right now, so we're going to divide by negative 8. And I'll do the same thing to the 56. Negative 8j divided by negative 8 is positive 1j. 56 divided by negative 8 is negative 7. And we just divided by a negative number, so that will reverse the symbol. J is less than negative 7. So we're going to find negative 7 on the number line. We can't be equal to it, so we're going to put an open circle on negative 7. And the values that are less than that are to the left, so we'll shade all of these values, and we will bold the arrow in the left-hand direction. In our last example, we have 1/2 k minus 1 is less than or equal to 4. Our variable term is on the left. It's got the constant negative 1 with it, so we'll start by adding 1 on each side. On the left, negative 1 plus 1 is 0, leaving us with 1/2 k. On the right, 4 plus 1 is 5, and adding will preserve the symbol, so 1/2 k is less than or equal to 5. Now we need to get the value of k. All right, k right now is being multiplied by 1/2. Since that's a fraction, instead of dividing by the fraction, I'm going to multiply by the reciprocal of that fraction. The reciprocal of 1/2 is 2 over 1, which is the same as 2. So I'm going to multiply both sides by 2. I'm going to multiply the left by 2 over 1. On the right, I'm just going to put to multiply by 2. All right, on the left-hand side, my 2 in the numerator and my 2 in the denominator can simplify down to 1s. So 1 over 1 times 1 over 1k is just our 1k, which is what we're looking for. On the other side, 5 times 2 is 10. We just multiplied by a positive number, which is going to preserve the symbol. So k is less than or equal to 10. So we're going to find 10 on the number line. Since we can be equal to 10, we're going to put a closed circle on 10. And now we need all the numbers that are less than that, so we're going to shade all of the values that are to the left. Any one of these values could be a solution to the inequality, and don't forget to bold the arrow in the left-hand direction as well. Okay, so any number to the left of 10 would be a solution, any number to the right of 10 would not be a solution, and it's a closed circle, so 10 would be a solution as well.